We're again going to be working with radicals today. We want to be able to add, subtract, multiply, and divide when you have a radical expression. So we'll start with adding and subtracting. You can add and subtract radicals in the same manner as adding and subtracting monomials. You only can add or subtract if there are like terms, or in this case, like radicals. So if you see that the radical has the exact same index, which means like the same type of root, whether it's square root, cubed root. Also, you need the exact same stuff underneath the square root, which is called the radicand. So if both of those match up, then what you can do is add the numbers in front of the radical sign to get a simplified answer. In this case, if we added these up, 2 plus 6, we would get 8 cubed roots of 3a. Okay. The second example is no good. Even though we have the same index or same type of radical, in this case a cubed root, what's underneath the radical sign, the radicand is different. It's not the same. So these would not be able to be added together. Same here. If you're trying to, even though this stuff underneath is the same, if one's a cubed root and one's a square root, those cannot be added together. So you got to have the exact same type of radicals in order to add them. So let's look at some examples here. In the first one, they want us to subtract and add these radicals. Well, the way the problem is now, we cannot subtract or add these because 12, 27, 48, those are all different numbers under the radical sign. So these would not be able to be added right the way they look right now. But what we can do is try to simplify and see after we simplify if we can't then add and subtract these together. So what we want to look for are those perfect square numbers once again, like 4, 9, 16, 25, 36, all those perfect square numbers, and I'm not going to list them all out because we've done them before. But we're looking to see, does any of those numbers exist in this example? Well, 12 there is. 12 is the same as 4 times 3, 4 being a perfect square. In 27, there is a 9, which is a perfect square. 9 times 3 is 27. With 48, you could go a couple routes. 4 is a perfect square, but there's even a bigger one of 16 that divides into 48. 16 divides into 48 3 times. So breaking these up then into smaller radicals here, this would be the same as square root of 4 and square root of 3. Using properties we talked about in the last notes, that'd be square root of 9 and square root of 3. And here, square root of 16 and square root of 3. Then simplify the one you can. So we know square root of 4 simplifies to 2. Square root of 9 simplifies to 3. And square root of 16 simplifies to 4. So now let's multiply these numbers together here in front. Okay, that's just math that you've done before. We get 4 square roots of 3. Here would be 9 square roots of 3 and 8 square roots of 3. Now notice that all after simplifying, these radicals are the same. Since they are the same, then we can subtract and add these up just like any math problem. So now we move left to right and see what you get. 4 minus 9, adding these first two together would give us negative 5 square roots of 3. Now if we add 8 to that, the final answer would be 3 square roots of 3. So if you put 3 square roots of 3 in your calculator, it should give you the same approximation as all that stuff we started with up on top. But this is much more simplified answer on bottom. Let's try another one. Number 2, we want to, again, simplify kind of the same way we did before. Why don't you pause the video and see if you can simplify these radicals? All right, let's see how you did. Square root of 8 is the same as 4 times 2. But 4 being the perfect square, 32 is 16 times 2, 16 being the perfect square, and 18 is 9 times 2, 9 being the perfect square. So if you simplify these, square root of 4 is 2. Square root of 16 is 4. And square root of 9 is 3. And then we want to multiply first here, so we can multiply our numbers together. we get 6 square roots of 2 plus 20 square roots of 2 minus 12 square roots of 2. Now you just want to add these numbers up. 6 plus 20 is 26. 26 minus 12 gives us 14 square roots of 2. That would be the final simplified answer. Hopefully you got to that part. All right, number 3. Now we work into multiplying here. Okay, we got parentheses times parentheses. If there's nothing in between these parentheses, we got a times going on here. So just like you would do with two binomials, we want to multiply these together. If you want to use the little FOIL acronym to help you, do that. But we want to multiply the first, the outside, the inside, and last. Basically distribute all the way through. Now, when you're multiplying, you want to only multiply numbers outside the square root with other numbers outside the square root, numbers inside the square root with other numbers inside the square root. So let's start doing this. When we multiply those first ones, 3 times 2 is going to give us 6 square roots of 5. Okay, now when we multiply the last one, so when we multiply these two here, we got 3. Okay, this 3 right here. Now, both of these, the 5 and the 3 are inside the square root, so we want to multiply those together. 5 times 3 would be 15. Okay, do the same thing now here. We want to multiply these two numbers outside the square root, minus 4 square roots of 3. And then when we multiply these last ones, we're multiplying the two numbers inside the square root. So we get negative 2 square roots of 3 times 3 is 9. All right, so now we want to look and see if we can simplify any of these radicals similar to how we did on the last two problems. It looks like there are no perfect squares that go into 5. There's also no perfect squares that go into 15, so we can't simplify either of those. Same with 3, no perfect squares. But 9 itself is a perfect square. So let's simplify that. That would be the same as 2 times 3. And we know 2 times 3 would be the same as 6. Okay, so now at this point you want to check, are there any of these that we can add and subtract together? And in this case, no. This is as far as we can go on this one. None of these radicals are the same, and so we don't want to add them together when they're not the same. There's no more simplifying to do on this problem. So only when the stuff under the radical is the same can you combine and add those or subtract those together. Why don't you pause, try number 4 out, and see what you get for that one. All right, let's see how you did. If we multiply these first ones, we want to multiply the 5 and 5 together because they're both outside. That's 25. And then we want to multiply these numbers inside the square root, 3 and 3. That'd be 25 square roots of 9. All right, now let's multiply the last ones. And we'd get 30 square roots of 3. Okay, now we're multiplying the inside ones. That'd be minus 30 square roots of 3. And then finally the last ones. If we multiply negative 6 and 6, we get negative 36. Okay, now we want to simplify. It looks like right away here I see we could cancel these middle terms out because it's the same stuff under the square root. One's positive, one's negative. So that cancels out. Also I see here square root of 9, that's a perfect square. So that would be the same as square root of 9 is 3. Okay, now we want to keep simplifying. 25 times 3 is 75. And we can even combine these numbers together. All that stuff at the top actually simplifies all the way down to an answer of 39. Kind of crazy that those two terms would equal a whole number there, but they do. So that's how you multiply and simplify those types of problems. All right, now our next one. Now we get into some division stuff. We got one term divided by another. Now on this problem, don't do this. Don't say we can cancel out those square roots of 3's. It looks like you should be able to, but you can't. And the reason is, anytime you see plus or minus in the problem, this stuff is grouped together and this stuff is grouped together, which means you can't cancel out unless they are exactly the same. So here we can't do any canceling. So what we want to look for next is can we get rid of the radical sign on either one of these? Okay, and usually what we want to do, just like we talked about before, is simplify the denominator. Okay, or what we called that before was rationalize the denominator, which means get rid of the radical sign in the denominator. Because oftentimes, especially like on the ACT test, you're not going to see radicals listed in the denominator. So how we do that, it's kind of similar to that last example we did. Notice that last example. Remember our answer came out to be a whole number? Why did that happen? Well, let's go back and look at the problem itself. If you look at the problem that we started with here, notice these are the same, 5 squared roots of 3, 5 squared roots of 3, and the last number was the same, 6 and 6. The only difference was the sign in between them. One was positive and one was negative. Anytime you multiply by the exact same stuff, just changing the sign, you're always going to end up with a whole number answer. And that's called multiplying by a what's called conjugate. That's a math term. Conjugate means the same stuff, you just put the opposite sign. And whenever you do that, you always get a whole number to come out. So what we're going to do to rationalize the denominator here is multiply by the conjugate. Now, some people might think, well, Mr. Johnson, if we just multiply by square root of 3 here, like we did before, you could rationalize the denominator. Well, it looks like that should work, but problem is you got to multiply that square root of 3 to both things. And so even though this square root of 3 times square root of 3 would equal square root of 9, which is 3. Now you're just stuck with a square root over here. So just multiplying by square root of 3 doesn't rationalize it. We're going to multiply by the conjugate. So we're going to multiply the bottom by the exact same two things, 5 and square root of 3. We're just going to do the opposite sign. So here we had a plus. We're going to go minus on this second one. Now, you can't just multiply only to the bottom. That's changing the problem. So whatever we multiply to the bottom, we're also going to need to multiply to the top. So whenever you multiply to one part of the fraction, you always got to multiply to the other side. So what we're going to do now is multiply these out similar to what we did on the last two problems. We're going to FOIL those out, multiply them out. Let's start with the bottom because the bottom is kind of cool here. We'll see a lot of stuff cancel out. 5 times 5 is going to be 25. If we multiply the outside ones, we get minus 5 square roots of 3. If we multiply the inside ones, we're going to get plus 5 square roots of 3. And if we multiply the two last things here, we get minus, because one's positive, one's negative. We get minus square root of 9, because 3 times 3 is 9. And we know square root of 9 is going to simplify to 3. Okay, well, notice what happens here. Cancels out, cancels out. That always happens when you multiply by the conjugate. So what's going to be left in our denominator then is 25 minus 3, which is the same as 22. So our denominator does go down to a whole number. Now, we can't just do that, though. We also got to simplify. Now, what does our numerator simplify to? So again, we're going to have to multiply, distribute. If you want to think FOIL, do that. So 1 times 5 is 5. 1 times negative 3, square root of 3 is negative square root of 3. Now multiply the inside ones, minus 5 square root of 3, and the last ones. And this is going to be plus, because it's a negative times a negative. And square root of 3 times square root of 3 is square root of 9, which again we know is going to be 3. So simplifying this out now, we got 5. These are similar radicals. They're both square roots of 3, so we can subtract these. Now, this one we see has a 5. This one didn't have a number in front, so anytime there's no number, know that it's 1. So we got negative 1 minus 5, that's going to be minus 6 square roots of 3. And again, we know square root of 9 here is 3. So finally, last step, looks like we can add these two numbers together. 5 plus 3 is 8 minus 6 square roots of 3. And that would be a simplified answer. It's rationalized. There's no more number or no more radical sign in the denominator. Now, one thing to keep in mind, this is a pretty good answer. It is rationalized, but if this was the ACT, you probably still wouldn't see that answer as one of your options. And the reason is we can simplify it just a little bit more. 22, 6, and 8, there's a number that divides into all those, 2. So the last thing we could do is say, okay, how many times does 2 go into all those, and simplify it a little bit more. 2 goes into 8 4 times. 2 goes into 6 3 times. And 2 goes into 22 11 times. That would probably be the most simplified answer you'd see on the ACT. All right, let's try another one of those ones where we want to rationalize the denominator by multiplying by the conjugate. So since we want to get the denominator rationalized, multiply by the conjugate. Conjugate's going to be the exact same thing, just opposite sign. So since this is a plus, we want to put a minus there. And whatever we multiply to the bottom, we need to multiply to the top. So let's multiply this out now. On top, we're going to get 3 times 6 is 18. 3 times that's going to be minus 3 square roots of 5. The inside ones now, minus 12 square roots of 5. And the last ones, negative times the negative is going to be positive 2 square roots of 5 times 5 is 25. On the bottom, we should see a bunch of stuff cancel out here. 6 times 6, 36. Minus 6 square roots of 5 plus 6 square roots of 5. And then the last ones would be minus square root of 25. Okay, now we want to simplify. Right away you should see those cancel. Okay, so we got 36, and we know square root of 25 here is the same as 5. On top, we got some simplifying we can also do here. These are like radicals, so we can add those together. Negative 3 minus 12 is negative 15 square roots of 5. Also, we know 25 here is also one that simplifies. So we got plus 2 times 5. Okay, simplifying further, we can do 2 times 5. 2 times 5 is 10. Also, we can combine these ones on the bottom. Looks like that would be 31. Still, one more thing we can do. Got some like terms here. Add those together. 28 minus 15 square roots of 5 over 31. This one doesn't simplify any farther because there's no numbers that go into 28, 15, and 31. Okay, that's called rationalizing the denominator, and we do it by multiplying by the conjugate. All right, 2 more kind of geometry applications on the back. This one came off of practice ACT. It says find the perimeter and the area of this rectangle. We know how to find both perimeter and area. Perimeter, no matter what the shape, always you want to just add up all the sides. So let's see what we get when we add up all the sides here. We'd have square root of 8 plus there'd be another square root of 8 opposite, and then 3 plus 6 square roots of 2, and then opposite that there'd be another 3 plus 6 square roots of 2. So the perimeter would be whatever happens when you simplify that. Well, let's simplify down here. Let's check our radicals first. Square root of 2 definitely does not simplify. Does square root of 8? Yeah, square root of 8 simplifies. The perfect square there being 4. 4 times 2 is going to be the same as 8. Over here, we could simplify a little bit here. 3 plus 3 is 6. And these are like radicals, so we could add those together. That'd be 12 square roots of 2. All right, so let's keep simplifying here. Our perfect square. We can split these apart using the multiplication property we talked about. And then we know 4 is the same as, square root of 4 is the same as 2. So finally, we want to look, can we do any last simplifying? Yeah, these are all like radicals. That one, and that one. They're all square roots of 2. So add the numbers in front. 2 plus 2 is 4, plus another 12 would be 16 square roots of 2. plus 6. So that would be the simplified perimeter. For area of a rectangle, length times width. So in this case, it would be square root of 8 times 3 plus 6 square root of 2. Okay, we know when you are multiplying with this, we got to distribute. Okay, don't multiply the 3 and 8 together here because one's under the square root, one's outside. So we'd write that as 3 square roots of 8. Plus, if we multiply the other one now, it'd be 6. Multiply the two numbers under the square root, and we get 16. Now we want to look, do either of those simplify? Yeah, in fact, they both do. There's a perfect square in both. Here it'd be 4 and 2. And then actually 16 itself is a perfect square. Square root of 16 is 4. Simplifying further then, 6 times 4 is 24. Our perfect square here of 4 equals 2. And so it looks like the final answer on this one's going to be 6 square roots of 2 plus 24. That would be the simplified answer you'd see on the ACT. All right, one other one. This also comes off a practice ACT. It says find the hypotenuse of a right triangle that has legs this length and this length. Okay, on a problem like this, if you don't get a diagram like we had on the last one, draw out a diagram. We got a right triangle. They want us to find the hypotenuse, which is the long side. Remember, this side's the hypotenuse. Always across from the right angle. And the other two sides, they give us the two legs are 2ab squared, and the other one is 6ab squared. Okay, well, how do we find this missing length of the hypotenuse? Well, anytime you're dealing with three sides on a right triangle, you come back to our good old equation here of a squared plus b squared equals c squared, the Pythagorean theorem. That's what we want to be using here. So this is our side A, B, hypotenuse always is C. So let's solve this out. If we substitute in, we got 6ab squared, and then it's being squared plus 2ab squared, also again squared equals c squared. We want to solve for c. What's c? What's the hypotenuse? So we got to start out by squaring everything here. Now, since there's no plus or minus in these terms, we should just go through and square everything. So 6 squared is going to be 36. A is going to get squared, and B is going to get squared. When you got power to a power, we want to multiply those, so that's going to be to the 4th power. So do the same thing on the next one. 2 squared is 4, A squared, B to the 4th. All right, can we add these together? Yep, these are like terms. If we add them up, we get 40 A squared, B to the 4th. One mistake that often happens on a problem like this is that when adding, people do this and put A to the 4th, B to the 8th. No, we don't want to do that. You're not increasing the powers when you're adding like terms. You want to keep them the same. Okay, just like if I asked you what's 3x plus 5x, that's 8x, not 8x squared. We won't do that. It's just 8x. You're just adding like terms. So the variable shouldn't change when adding and subtracting. All right, we're not quite done yet though. We want just c, not c squared here. So to undo power 2, we know we need to square root. And so c is going to equal the square root of 40 a squared b to the 4th. Okay, now go back to what we did yesterday. To simplify that, we want to separate stuff we can take the square root of and stuff we can't. There is a perfect square in 40 of 4. 4 times 10 is 40. So let's separate this into radical that can simplify and one that cannot. The stuff that can be simplified is 4, a squared, and b to the 4th, all simplify. 10 does not simplify. And so our simplified answer would be, now let's take the square root here. Square root of 4 is 2. Square root of a squared is a. Square root of b to the 4th is b squared. And then finally we got the square root of 10 that won't simplify. That would be the final answer. All right, try some of these out now on the practice.